When a meter and fuse disconnect are located at grade level and a distribution panel is installed on the roof of a building, a main breaker is required in the distribution panel on the roof. The core reason stems from the need for a readily accessible means to disconnect the power at or near the distribution panel. While the fuse disconnect at grade serves as the service disconnect, providing a means to cut off power to the entire building, it does not fulfill the requirement for local overcurrent protection and a disconnecting means at the distribution panel itself. The National Electrical Code (NEC) mandates overcurrent protection and a disconnecting means at the point where conductors receive their supply. In this scenario, the distribution panel on the roof is fed from the service disconnect at grade. Therefore, the panel must have its own overcurrent protection, typically in the form of a main breaker. Using a main lug-only MLO panel in this situation would violate the NEC. An MLO panel is designed to be fed from a breaker in another panel, providing it with overcurrent protection upstream. However, without a main breaker in the roof distribution panel, there is no local overcurrent protection for the conductors feeding the panel, nor is there a readily accessible way to energize the entire panel for maintenance or in the event of a fault. There are several reasons why a main breaker is required in the distribution panel. Firstly, it provides overcurrent protection. The main breaker protects the panel and the conductors feeding it from overloads and short circuits. Without it, a fault in the panel or downstream circuits could cause damage to the equipment and pose a fire hazard. Secondly, it serves as a local disconnect. The main breaker allows electricians and other qualified personnel to quickly and safely de-energize the entire panel for maintenance, repairs, or in emergencies. This is especially important when the service disconnect is located some distance away at grade level. Thirdly, the NEC requires it. The NEC mandates a disconnecting means and overcurrent protection at the point where conductors are tapped from a power source. In this case, the distribution panel is the tap point, necessitating a main breaker. Now let us consider the practical implications of this requirement. Imagine a scenario where a fault occurs in one of the circuits fed from the distribution panel on the roof. Without a main breaker in the panel, the only way to de-energize the affected circuit would be to trip the fuse disconnect at grade. This would shut off power to the entire building, causing unnecessary disruption and inconvenience. With a main breaker in the distribution panel, the electrician could simply trip the main breaker, isolating the fault and allowing the rest of the building to remain energized. Furthermore, consider the safety aspect. Working on electrical equipment always carries a risk of electric shock. Having a readily accessible disconnect at the distribution panel allows electricians to quickly de-energize the equipment before starting work, minimizing the risk of injury. Without a main breaker, they would have to rely on the service disconnect at grade, which may not be easily accessible or may require them to travel some distance. It is also important to note that the size of the main breaker in the distribution panel must be appropriately sized to protect the panel and the conductors feeding it. The breaker must have an amperage rating that is equal to or less than the ampacity of the conductors, and it must be coordinated with the overcurrent protection at the service disconnect. The NEC provides detailed guidelines for sizing overcurrent protection devices based on the type of conductor, the application, and other factors. Consulting with a qualified electrician or electrical engineer is crucial to ensure that the main breaker is properly sized and installed. To further illustrate the importance of this requirement, let us explore a few specific examples. In a commercial building with multiple tenants, each tenant may have its own subpanel fed from the distribution panel on the roof. Without a main breaker in the distribution panel, a fault in one tenant's subpanel could trip the service disconnect at grade, affecting all tenants in the building. This could lead to significant business disruption and financial losses. Similarly, in a residential building with multiple apartments, a fault in one apartment's electrical system could affect all apartments if there is no main breaker in the distribution panel on the roof. This could create safety hazards and inconvenience for the residents. In both of these examples, a main breaker in the distribution panel would provide a localized means of disconnecting the power, minimizing the impact of a fault and improving safety. It is also important to consider the potential for future expansion or modifications to the electrical system. As the building's electrical needs evolve, it may be necessary to add new circuits or upgrade existing ones. With the main breaker in the distribution panel, it is easier to make these changes without affecting the entire building. The main breaker provides a convenient point of isolation, allowing electricians to work on the panel without disrupting the power supply to other areas. In contrast, if there is no main breaker, any modifications to the distribution panel would require shutting off the service disconnect at grade, which could cause significant inconvenience. Now let us address some common misconceptions about the use of MLO panels. Some people may mistakenly believe that an MLO panel can be used in any situation where a distribution panel is required. However, this is not the case. MLO panels are specifically designed for use as subpanels where they are fed from a breaker in another panel. They do not provide their own overcurrent protection and are therefore not suitable for use as service entrance equipment or as distribution panels that are directly fed from a service disconnect. Another misconception is that the fuse disconnect at grade provides sufficient overcurrent protection for the entire electrical system, including the distribution panel on the roof. While the fuse disconnect does protect the service conductors from overloads and short circuits, it does not protect the conductors feeding the distribution panel from faults that may occur within the panel itself or in the downstream circuits. The main breaker in the distribution panel provides this additional layer of protection. It is also important to emphasize that the NEC is a minimum standard. Local jurisdictions may have additional requirements that go beyond the NEC. It is essential to consult with the local electrical inspector or building department to ensure that the electrical installation complies with all applicable codes and regulations. Failing to comply with these codes can result in fines, delays, and even the rejection of the installation. In summary, the requirement for a main breaker in the distribution panel on the roof when the meter and fuse disconnect are at grade is a critical safety measure that is mandated by the NEC. The main breaker provides overcurrent protection, serves as a local disconnect, and allows for future expansion or modifications to the electrical system. Using an MLO panel in this situation would violate the NEC and could create a dangerous situation. Consulting with a qualified electrician or electrical engineer is essential to ensure that the electrical installation is safe, code compliant, and meets the building's electrical needs. Remember to always prioritize safety when working with electrical equipment and to follow all applicable codes and regulations. Ignoring these requirements can have serious consequences. Firstly, personal injury and property damage. Failure to install a main breaker can increase the risk of electrical shock, fires, and equipment damage. Secondly, code violations and fines. Non-compliance with the NEC can result in fines and penalties from local authorities. Thirdly, insurance issues. Insurance companies may deny claims if the electrical installation is not code compliant. Fourthly, liability. Building owners and contractors can be held liable for damages or injuries resulting from code violations. It is important to remember that electrical codes are in place to protect people and property. Following these codes ensures a safe and reliable electrical system. Therefore, always prioritize safety and code compliance. Now, let's dive deeper into the technical aspects of selecting the right main breaker for your roof-mounted distribution panel. Several factors need consideration to ensure proper protection and compliance. Firstly, ampacity of the feeder conductors. The main breaker's ampacity must be less than or equal to the ampacity of the conductors feeding the distribution panel. This protects the conductors from overheating and potential fires due to overloads. Refer to NEC Table 310.15 for conductor ampacity based on size, insulation type, and installation method. Secondly, interrupting rating. The interrupting rating of the main breaker must be sufficient to handle the available fault current at the distribution panel. Fault current is the amount of current that would flow during a short circuit. Consult with your local utility or qualified electrical engineer to determine the available fault current at your location. Using a breaker with an insufficient interrupting rating can lead to breaker failure and potential equipment damage during a fault. Thirdly, series rating. If the distribution panel uses a series-rated system, ensure the main breaker is compatible with the downstream breakers. Series rating allows for the use of breakers with lower interrupting ratings downstream, provided the main breaker has a sufficient interrupting rating and the system is properly coordinated. Consult the panel manufacturer's instructions for specific series rating combinations. Fourthly, voltage rating. The voltage rating of the main breaker must be equal to or greater than the system voltage. In a typical single-phase system, the voltage rating would be 120 volts or 240 volts. In a three-phase system, it could be 208 volts, 277 volts, or 480 volts. Using a breaker with an insufficient voltage rating can lead to breaker failure and potential safety hazards. Fifthly, frame size. The frame size of the main breaker must be compatible with the distribution panel. The frame size determines the physical dimensions of the breaker and its mounting requirements. Refer to the panel manufacturer's specifications for the correct frame size. Sixthly, type of breaker. Different types of breakers are available, such as thermal magnetic breakers, electronic trip breakers, and instantaneous trip breakers. The type of breaker best suited for your application depends on the specific requirements of the system. Thermal magnetic breakers are the most common type and provide both overload and short circuit protection. Electronic trip breakers offer more advanced features, such as adjustable trip settings and ground fault protection. Instantaneous trip breakers are designed to trip very quickly in response to a short circuit. Seventhly, environmental conditions. Consider the environmental conditions in which the distribution panel will be installed. If the panel is exposed to extreme temperatures, humidity, or corrosive substances, select a breaker that is rated for those conditions. Some breakers are specifically designed for outdoor use and are protected from the elements. Now, let's discuss the installation process for the main breaker. Firstly, to energize the panel. Always to energize the distribution panel before working on any electrical components. Use a voltage tester to verify that the power is off. Secondly, remove the panel cover. Carefully remove the panel cover, exposing the interior of the panel. Thirdly, install the breaker. Install the main breaker in the designated location in the panel. Ensure that the breaker is securely mounted and properly connected to the bus bars. Fourthly, connect the conductors. Connect the feeder conductors to the main breaker terminals. Ensure that the conductors are properly sized and insulated. Tighten the terminal screws to the manufacturer's specified torque. Fifthly, verify connections. Double-check all connections to ensure that they are tight and secure. Loose connections can cause overheating and potential fires. Sixthly, replace the panel cover. Carefully replace the panel cover, ensuring that it is properly aligned and secured. Seventhly, energize the panel. Energize the distribution panel and test the main breaker to ensure that it is functioning properly. Use a voltage tester to verify that the voltage at the panel is correct. Now, let's address some frequently asked questions about main breakers and distribution panels. Question 1. What is the purpose of a main breaker? Answer. The main breaker provides overcurrent protection for the distribution panel and serves as a local disconnect. Question 2. Can I use an MLO panel instead of a panel with a main breaker? Answer. No. An MLO panel cannot be used as a service entrance panel or as a distribution panel that is directly fed from a service disconnect. Question 3. How do I size the main breaker? Answer. The main breaker should be sized according to the ampacity of the feeder conductors and the requirements of the NEC. Question 4. What is the interrupting rating of a breaker? Answer. The interrupting rating is the maximum amount of fault current that a breaker can safely interrupt. Question 5. What if the panel is outdoor? Answer. For outdoor installations, use a breaker that is specifically designed for outdoor use and is protected from the elements. And finally, let's talk about the importance of regular maintenance for your main breaker. Firstly, visual inspection. Regularly inspect the main breaker for any signs of damage, such as cracks, corrosion, or loose connections. Secondly, testing. Periodically test the main breaker to ensure that it is functioning properly. This can be done using a breaker tester or by manually tripping the breaker. Thirdly, cleaning. Keep the main breaker clean and free from dust and debris. Use a vacuum cleaner or a soft brush to remove any accumulated dirt. Fourthly, torquing connections. Regularly check the torque of the terminal screws to ensure that they are tight and secure. Loose connections can cause overheating and potential fires. Fifthly, replacement. Replace the main breaker if it shows any signs of wear or damage, or if it fails to function properly. Following these maintenance tips will help ensure that your main breaker continues to provide reliable protection for your electrical system. By understanding the importance of main breakers in distribution panels, following the NEC guidelines, and performing regular maintenance, you can ensure a safe and reliable electrical system for your building. Remember, when in doubt, consult with a qualified electrician or electrical engineer to ensure that your electrical installation is code compliant and meets your specific needs. Electrical safety is paramount, and taking the necessary precautions will protect both people and property.